Hello. Sorry, a bit sweaty. It's hot. Uh, it's the last step of our advanced dice game. Uh, cool. Sorry, I don't know why I'm distracted. Okay, so we've got we have got two more options here: the small straight and the large straight, and we are going to create an algorithm that checks for consecutive values in any order, resulting in a score of 30. A large straight is when all five have consecutive values. A small straight is when four of those, and then we'll do the whole update thing. So my backup plan is to just search for a way to check the numbers are in a consecutive order. But what I actually also want to do is try and design one. So I'm going to spend I'll time box this to 10 minutes. If I haven't got one in 10 minutes, then I'm not going to get one. So for it to be consecutive, for a small, it will always have to be 1, 2, 3, 4, or 4, 3, 2, 1. Not in those numbers, but I can have a straight either in the first 4 digits and the last 4 digits from either end, right? So backwards or forwards, I can have the first 4, the last 4 be consecutive. For the large straight, for the large straight it's much more simple. It will either be backwards or forwards. Now how can I check that numbers are consecutive? If they're consecutive, taking the larger from the smaller will always be equal to 1. That will always be equal to 1. Yeah. If any two numbers are consecutive, the difference between them will always be 1. Right. So for the large straight, I can test for the large straight, I always want to know, is it backwards or is it forwards? So is array at 0 greater than array at 1, right? And if it's this is array at 1 greater than array at 0. I can always do this test, right? So backwards or forwards, I can always do this test, because if it will always ever be one way, it will always ever be 1, 2, 3, 4, 5, or 5, 4, 3, 2, 1. It will never be the opposite, right? Yes. So if it's backwards, then the array at 1 will be bigger than the array at 0, because 2 will always be bigger than 1. Yes. And if it's forwards, then array at 0 will be greater than array at 1. Yeah. And I can do that. So actually, for both of them, I will always in the middle, because it's only 5. So always in the middle. Oh, but okay. I can perform this test in the middle. Because whether it's 1, 2, so if it's a small straight and the first number isn't in the array, so maybe it's 9, 1, 2, 3, 4, then array at 2 will be bigger than array at 1, or if it's the other way around, then it's 1, 2, 3, 4, and then 7. Then array at 3 will be, so I can do this test in the middle for whether or not the consecutive order is ascending or descending. Okay, so I can always do array at 2, which is the third, and array at 1, which is the second, and array at, so array at 2 will be greater, no, if it's backwards, so if it's 4, 3, 2, 1, then array at 2 will be greater than array at 1. If it's forwards, if it's 1, 2, 3, 4, then array at 1, array at 1 will always be greater than array at 2. Basically, I can ignore the first or the last digit for my small straights. So backward or forwards, regardless of large or small, I can make this test to see if it's ascending or descending. And then to check if any two numbers are consecutive, I just have to subtract the lower from the higher. So once I decide if it's backward or forwards, I can use some sort of loop to check that it keeps sorry, I'm responding to a message. Sorry. Oh no, I just lost. Yeah, so I can use a. So let's see if there is something. Okay, so every. Every could be one. So every could be an option. Let's see. It would be cool if I could test that every or most. Unless I test for every, for all 5. Okay, so I could use every. Alright, so we've got 10 minutes. We're 10 minutes in. But I think I'm happy with this. So I could use every method to test if the smaller the each one is one more than the next. So yeah, so let's do this. So time box is over because I think I have it now. So my consecutive test is the larger minus the smaller should be 1. So that's my consecutive test. And if it's forwards, then the larger will be the next one. If it's backwards, then the larger will be the previous one. If that makes sense. It will make sense. And I can use every to test for that. If every passes the first time, then I know it is. If every passes the first time, then I know it's a large straight. If every fails the first time, then I want to run it again, but for, depending on if it's forward or backwards, the last 4 or the first 4. And if that passes, then I've got a small straight. Okay. Okay. I think I have the pseudocode. Kind of. for my check for straights, and I think it's in the right order as well. So okay, actually, this is not in the right order. So I think from here is when. So I'm first going to check for the sort. So check if ascending or descending. At this point, we don't know if we have a straight, but because we're checking in the middle, we can always check if the middle is larger than the one before it or smaller than the one before it. If it's larger than the one before it, then if it is in a straight, it's going to be in an ascending straight. If it's smaller than the one before it, then if it is in the straight, it's going to be a descending straight, and that's regardless of whether or not it's a large or a small straight. So we actually only have to test. We only have to test one way, actually. So check if ascending or ascending by checking if array at 2 is greater than array at 1. If true, then it's ascending. If false, then it's descending. Okay, so I don't really care about this anymore because this is the test I'm going to carry out. Because we're only dealing with 5, the middle will always have to be in the straight if it is a straight. And if it is a straight, regardless of if it's smaller or bigger, then it would be, yeah, that's the test. I only need to test that. Is array at 2, which is the third, greater than the one before it? If so, then it's ascending. If it's not, and it's smaller than the one before it, and I'll use less than or greater than, and not if it's greater than or smaller than, and not greater than or equal to, because I don't want it to be equal to. If it's equal to, then we don't have a straight. Yeah. Yeah, okay. So I think I'm happy with that. Okay. So once I determine if it's ascending, or descending, I can then go on to test if it is indeed a straight. This might not be the most efficient, but if it works worse, and then I can check for a red one. So my consecutive test is the larger minus the smaller equal to 1 for each element there. And that's where I use every. Yeah. Yes. So there I use the iterative method every, and that will be based on the order. If it's ascending, then I'm going to be doing that way. If it's descending, I'm going to be doing that way. So I'll have to write this twice. If it passes the first time, then we've got a large straight. If it doesn't, we'll rerun it, but we won't include the first if it's ascending. No, we can't do that because it could be 9 1 2 3 4, or it could be 9 4 3 2 1. So I might have to run it 3 times. First without the first one, and then without the last one. Yeah. Run again for a subset way without the first value. If that fails, run last time without the last value. Then if it passes, we have that. Yeah. Okay. So I'm going to have to write smaller functions that just test that and get called. Maybe with a push or a pull. A pull, yeah. Cool. I need to find this, so this is not yet done. I'll put on this on. Okay. So then that's my pseudocode. That's what I'm gonna do. Cool. I'm gonna save this because this will fail. I'm gonna save this on my notes and then I'm gonna try that tomorrow. So that's the plan. I think this should work. Yeah. Alright. Keep showing up, guys.